This is a story about more than 100 million architects. All around the world, they're building their homes. They don't use blueprints, but their designs are foolproof. They don't have bulldozers or cranes, but they move mountains. And they don't speak a common language, yet they work together flawlessly. Who are these mystery architects? They are the honeybees, and this is their story. Welcome to AI Geo Wild. This is the first episode of the secret lives of bees. We start our journey at the heart of the hive, because any city needs a power plant, and here, the fuel is flower pollen. The worker bees travel up to 10 kilometers for pollen and nectar, carrying 20 milligrams loads that are 10 times heavier than themselves. Back at the hive, others process the nectar into honey, storing it in the hexagonal cells that make the combs. That's the real miracle of the hive. This is the most efficient design known to man. Yes, we know hexagons are strong, but the real mystery is how bees invented them. Their instincts tell them that hexagons fill empty spaces better than any other shape. If you pack circles, they leave gaps. Squares also leave gaps. Okay, only hexagons leave none. Plus, each hexagon has 6 identical sides, making it easier for bees to construct. But how does the construction work? Here's a bee on a mission. She's flying backwards and forwards, measuring the space between walls. Now, she touches one wall with her front legs, then the next with her back legs. With each touch, she leaves a special pheromone. After she finishes the circuit, another bee follows her path, laying down more pheromones. A third bee comes along and lays another layer on top. As the layers stack up, the comb grows. The bees haven't invented geometry, but they use it brilliantly. Each of these cells is the size and shape of a AA battery. The thickness of the cell walls, thinner than a sheet of paper, allows the hive to store 50 times their weight in honey, enough to last through harsh winters. And the strength of the whole structure comes from the individual walls, each made of beeswax, secreted by glands on the bee's abdomen. Now, let's see how this building works. First, a bee takes off its wax pants. Actually, it's called a wax gland, but we're calling it pants for fun. The pants are slightly concave on the inside and filled with liquid wax. The bee tilts its body forward, and the wax starts dripping onto the sticky surface of the honeycomb. It keeps dripping until a flake forms. The bee then uses its mouth to manipulate the shape of the flake, pulling it, stretching it, smoothing it. When the flake is perfect, it detaches and the bee moves on to the next one. The process continues until the entire comb is covered with flakes. Then a new team of bees takes over, melting the flakes with heat from their bodies and molding them into place. The result is so beautiful, it looks like glass blown by an artisan, but it took 8,000 bees 8 weeks to build it. Bees don't need air conditioning, but sometimes the hive gets stuffy. During hot summers, the temperature inside can rise above 30 degrees Celsius, which is deadly for bees. So when the hive gets too crowded and too hot, the bees line up at the entrance and beat their wings. Amazingly, they synchronize their wing beats and pump fresh air into the hive. If you looked closely, you'd see that each bee is flapping its wings slightly differently. Some flap faster, others slower, but together they create a constant stream of air. By the way, this is the background noise of a beehive. If you take a closer look at the ventilation fan, you'll notice that some bees are facing out and others are facing in. The ones facing out push the air towards the hive entrance. Those facing in pull the air away from the combs. Together, they form a convection current, constantly circulating air through the hive. Okay? And all this happens without any bee being in charge. The hive adjusts the airflow automatically, keeping the queen cool and everyone else alive. When winter arrives and temperatures drop below zero, the bees perform a different trick. They gather close together in a tight ball and vibrate their flight muscles. This generates heat and helps maintain a constant temperature inside the hive. Now you can see that some bees are on the outside of the ball, while others are on the inside. The outer bees shiver and generate heat. The inner bees conserve energy and stay warm. Every 15 minutes, the bees switch places so no one freezes. These bees are acting like a single organism, and scientists call this a superorganism. Let's go back to the hive and take a closer look at the structure, because there is more to it than meets the eye. There are two main parts. In the lower part, there are vertical combs where the larvae develop. The upper part has horizontal combs used for honey storage. You may wonder why the different levels, and it's all about efficiency. The lower combs are for raising new bees, and the upper combs are for food storage. Keeping them separate makes sense, because baby bees need peace and quiet, while adults come and go, looking for pollen and nectar. But the most important thing in the hive is the queen. Her job is to lay eggs, and she spends most of her life in the center of the lower combs. If the hive is attacked or threatened, the colony must defend itself. That's why guard bees patrol the entrance day and night. They sniff every newcomer and challenge them with a fight. Depending on the situation, they may use chemical warfare, biting, stinging, or even sacrifice themselves. The most common intruders are other bees, and guard bees identify them by their smell. However, other insects, like wasps, are met with a furious defense. Hundreds of bees surround and attack the intruder, biting and stinging until it's cooked alive. It's a brutal welcome, but it keeps the hive safe. And speaking of safety, the interior of the hive is like a maze. New bees get lost on purpose, so they learn the layout and can find their way back quickly. They follow landmarks like cracks or holes, and once they memorize the route, they can navigate the hive efficiently. If the hive is attacked, the bees close the entrance and defend only the inner chambers. So, even if some bees are lost, the hive remains protected. We talked about the power of the superorganism, but how does it work? Can thousands of bees act in unison? Okay. Well, it's partly thanks to the amazing dance of bees. You see, bees don't have a phone plan to communicate, but they somehow share information about the best places to collect pollen and nectar. They also dance to warn of impending danger, swarming, and even choosing a new queen. It's all about the waggle dance. When a scout bee finds a good source of pollen and nectar, it returns to the hive and dances in a special way. Other bees watch and learn the direction and distance from the new food source. Then they set off in that direction as bees communicate information about food sources, predators, and even the strength of wind through dance. But there's more to their choreography. It's believed that bees can pass on genetic information through the waggle dance, ensuring everyone is ready for what's next. Scientists think this knowledge could help us understand how bees adapt to climate change. But understanding the bees' dance is beyond the scope of this video. So we will understand more about bees on the upcoming videos on this series where we decode the bee code. For now, let's close this episode. Bees don't need plans or blueprints. They don't need a leader or an architect. It They build cities that we can only dream of. They build cities that perfectly balance engineering, architecture, climate control, defense, and organization. Cities that can survive for centuries. The bee's secret is instinct honed over millions of years. It's a legacy of nature's most successful builder. Thank you for joining us in this episode of AI Geo Wild. Subscribe for more updates. And remember, behind every great city, there's a lot of buzzing.